Hello, good day everyone. This is Rahul Bagadia. I am Chairman and Managing Director at P Manifold, and I welcome you all for this wonderful discussion today. I have very reputed and experts working globally in the green hydrogen space with me today. And as P Manifold, I again welcome and intend to use this discussions with the experts to see like how India has evolved with more definite mechanisms in its green hydrogen market development, and how will be the journey forward, and what further ecosystems needs to further be established. The topic that we will cover today is India green hydrogen market development mechanisms. And with this first webinar in series, what we are calling it as Hydrogen Global Insights, we intend to bring more such discussions with global experts across the value chain of hydrogen. Next, please. So running very quickly with our three expert speakers, we have Kiran Kumar Alla. Kiran is leading marketing at Plug Power for India. And in his earlier roles, I have always known Kiran a good friend, very strong on utilities, RE side, and a fairly good stint also on the fuel cell with Bloom Power in his earlier roles. So all in all, like he has covered all aspects of RE and reversible way of generating electricity through using fuel cell, and now using electricity to generate hydrogen, right? So he has a very expensive background in, I would say, the clean tech space on the operation side. So that's the value Kiran brings, and his current company Plug Power specialize in proton exchange membrane PEM electrolysers. So that's the expertise I'm hoping Kiran will discuss and bring to the table today. Our other speaker is Dr. Arvind Kumar Chandiran. Arvind is a good friend at IIT Madras. He is heading Center for Photo and Electrochemical Energy at IIT Madras. He holds patents, but his real expertise lies around water electrolysis, solar water splitting. He has worked on zinc air fuel cells, and he is also working extensively on CO2 electrolysis. Like while today we are focusing on water electrolysis, but Arvind has extensive experience in electrochemistry. And he's working with fair amount of stakeholders, and with Arvind and with IIT Madras, P Manifold is also working on a Government of India project supported by GIZ, where we are looking into recommending green hydrogen standards across the value chain. So Arvind brings fair deep expertise across the value chain, and in today's discussion we will learn more about like what are those R&D drivers for India, which can allow us increase local value addition, which is also expected from the current policy initiatives. My third friend, Vishwanathan Mahadevan. For some reason, I think Vishwanathan's camera is off, and Vishwanathan is managing director at Rensol Power, an electrical engineer, having worked in RE commercialization in his early ventures, and now focusing on electrolyzer development. So he has already prototyped and taking to commercial scale of alkaline electrolyzers. And that is the expertise around alkaline electrolyzer manufacturing and assembly that I will be looking upon Vishwanath to share his point of view. So overall, this will be the three expert speakers that I will be kind of discussing. I will encourage all of you to please keep sharing your questions in the Q&A dialogue chat box. Okay, here we go. Now we have Vishwanathan. Hi, Vishwanathan. So with these experts, let me just quickly introduce what I intend to do in today's discussion. We will be primarily focusing upon electrolyzer manufacturing, between the two technologies, alkaline and PEM. We will be trying to understand like how these technologies are working, what are their further technology roadmaps, and how these technology roadmaps will hopefully bring the cost reductions and improvement in terms of efficiencies, also improvement in terms of manufacturing and supply chains and local indigenizations. So that is the system engineering aspects on design and manufacturing that we will discuss with our stakeholders. We will also kind of try to delve into like what are the opportunities. Like the two of our experts come from companies who are into manufacturing and providing this technology. So what are the early candidates, opportunities, segments that they are looking that will benefit from their supplies? So trying to understand a little bit more about the evolving market conditions, both for exports and domestic consumption of green hydrogen. So that's the area. And we will also touch upon, given the second incentive is focusing on subsidies for hydrogen production, what it means, like what are the economics, like if we are doing water splitting by any technologies, what is the cost economics of producing green hydrogen as it stands today in India? What are those levers which can improve this economics for more, I would say, like matching up with other alternative technology costs today. So that's on the green hydrogen production that we will discuss. And towards the end, I am hoping that we will have some point of view on existing two mechanisms which are very recently announced by MNRE, and how as a country we use this opportunity to move forward. So with that, let me bring my colleague Sayali Agade. Sayali is leading hydrogen excellence practice at P Manifold, and she will share a brief context setting presentation, after which we will get into Q&A with our experts. And as I said, like please keep sharing your questions. We will try to address most of them in discussions today. So my sincere welcome to all the audience and to my fellow dear panelists. Over to you, Saili.
Yeah, thank you. I hope I'm audible and visible to everyone. So,
Yes,
hi
yes, sir.
everyone.
Yes, speak a little loud, and but that should be okay.
Sure. Okay. So, welcome to our today's webinar. And here I will first take you through our background slides on what the hydrogen stats are globally and in Indian context. And then we will also discuss the recent schemes which are launched by MNRE on the yeah. So regarding the demand side and the supply side. So yeah. So coming to our first slide, which is on the global hydrogen demand. So as we all know, like in our India and also globally, hydrogen is already in our end use application from our very past. So as we can see today, the share of hydrogen is roughly around 90 million tons per and the production capacity of per annum. So which out of which like almost 100% is gray hydrogen and which is getting produced from the SMR technique. But hello. Okay, so I will request everyone to just mute themselves. Yeah, that is fine. Thank you. As we can see in the base year, which is 2021, our overall hydrogen demand is 90 metric ton, which in coming future by 2050, it is going to 660 million tons. And like the difference which we can see from these both graphs is the demand is going 7 times higher, the expected growth which we can see. But here the share of green hydrogen we can see is significant. And when we are also looking into how this is accounting into the end use application, so we can see that majorly the in 2050 we can see the hydrogen application in the mobility sector, mostly in the industry sector, refinery sector, and the power generation sector. And currently, if we see the distribution in the end use application, so it is mostly industry and refinery where ammonia, methanol is getting used. So yeah, and once we are knowing that this is going to be the expected demand, then we also need to understand that what this expected growth in hydrogen will impact to. So as we can see in this particular graph, in the existing scenario as of 2021, we have roughly around 33 gigatons of CO2 uh, from all the sectors. And if we will not make any efforts or the interventions in the business as usual case, this will further go and will touch to 50 gigaton CO2 by 2050. So this is this graph where you can see this is with no transition and no intervention. But if we have to achieve our target of the net zero scenario by 2050 and we are implementing all these interventions, then we can see that we are able to reach like zero emission by 2050. And out of which, if we see the intervention, they are mostly around renewable energy, also electrification is forming a major share, and the hydrogen, which we can see it is 17%. So yeah, so this is how, and in today's session also we are going to talk about this 17 to 18%, which is forming roughly 22% of the global energy demand. So yeah. Mm, Coming to our next slide on our what is the Indian scenario. So firstly, if we will see the hydrogen demand by segment as of 2021, it is 5 million ton per annum of hydrogen in India, which is forming roughly 5 to 6% as of the global demand. And if we see its application across the sector, so it is again similar in the refinery and the industry sector, which was also at the global pace. But when we are looking when we are looking into the transition and how it will be in 2050 and what are its target, so we can see the expected growth is around 4 to 5 times. And here our target is like from 0% um, green hydrogen, we are aiming for 90% green hydrogen, and which is forming 28 million tons per annum of hydrogen demand. And if we see also the sector, these are roughly similar to what are as of for the global case. So this is how we can see the how hydrogen demand is going to be, and if and this is forming the 5% of the global demand in 2050 also. And if we are able to achieve this overall target, this will again impact. This will help us in reducing our the import bills. Like currently, if in 2021 we will see there are annual import bills of around 160 billion. So if you can see as in all sectors like oil, natural gas, coal, petroleum products, ammonia, everywhere we have to import. And here we have given also the stats of what that import quantity is, and we have also identified that how much this hydrogen has the potential in each sector. So as we can see in oil, there is almost 50% of the sector, there is the potential we see in, and this is the representative potential which we are giving in this particular pie chart. So like roughly we are thinking, we are rationalizing as 50% of hydrogen potential for this sector, and this can be in the refinery sector, in the mobility sector. Similarly for the coal, here in the production side we can have. Similarly for the ammonia, which is directly getting used as the synthetic fuel, so there 100% hydrogen potential, and is applicability and suitability is there, is what we are trying to say here. So, and this hydrogen potential at green hydrogen will eventually help us to reduce also our import bills in coming future. So this is how we are telling about the what hydrogen stats today, how is it going to be in future by 2050, and how is it impacting and what is its importance. So when we are coming to some initiatives, so India has already initiatives towards the green hydrogen, and they have taken steps forward. One such steps is the National Green Hydrogen Mission, which has already been approved by in 2023 now. And the major objective of this particular scheme is we have to make India also uh, the global hub for hydrogen production, for hydrogen usage, and also the export. So, this is the steps forward towards the Atmanirbhar Bharat also. And here we have given the major stats which were in the scheme, which was mentioned, like we are targeting for 5 million ton green hydrogen production annually, which by 2030, and where the electrolyzer capacity will be 60 to 100 gigawatt, and the total investment which was given was 8 lakh crore. So these are the, and this how what will it have the impact in terms of the import saving, in terms of emission saving, in terms of job creation. So all these stats we are giving, and when we are coming to the overall financial outlay in that particular scheme, so we can see that uh, that overall scheme has four components. One is site program, which has most of the financial outlay like given to, which is around 90%, followed by the pilot projects component, then R&D, and also the other mission components, which are capacity building and awareness. So if we are looking into the site program, which is our agenda in our today's discussion also, we are known that recently MNRE has launched two schemes under this site program, which are catering to both the demand and the supply side creation. So the, like here they are supporting the domestic manufacturer of domestic manufacturing of electrolyzer, which we can say the supply side support, and scheme 2, which is towards the incentivizing production of green hydrogen, which is on the demand side. So this is we will look into. So yeah, this is overall the India's hydrogen landscape key projects. So what we can see that there are already steps being taken in across the value chain, which is right from the production to distribution to storage to end use, and this is result of all the schemes and missions and initiatives which India has already carried out. So coming to now the scheme 1 of the site, which was the towards incentive schemes for the electrolyzer manufacturing, we can see that there is the overall capital outlay of around 4,000 crore out of the overall 17,000 crore which was given for that site program, and this is for the 5 years. The base incentive value which is given per kW is 4,400, and which is tapering down to 1,500 around in by fifth year. Uh, then even the performance incentives they have given based on the performance quotient and the efficiency. So with the minimum threshold of 56, and which is getting improved to 46 kW per kg of hydrogen, and even they have accounted for the local value addition. So while giving the incentives, they have accounted and had the balanced approach, like from the indigenization, which is the local value addition, then the efficiency also they have considered. They have also considered the technology, also the local cells. So here I'm not going in detail of each, but these are the parameters we have taken from that scheme, and how they have given the efficiency as, and what are the exact numbers. So these are what we can see here. But yeah, good initiative by MNRE and their work. So yeah, when we are coming to scheme 2, which is on the green hydrogen production. So here is what we can see the major capital outlay is falling, which is roughly around 1,300 crores for the period of 5 years. Here they are giving the incentives per kg of hydrogen, which is right from 50, then going and tapering down to 40, 30, and for 3 years this has been given. They have accounted for two energy sources. One is from electrolyzer and the biomass route, and yeah, so biomass has also been considered into this scheme. And there are some bidding capacity which they have reached the bidding capacity in two of the buckets, and there are some eligibility criteria also. So this is what we can see overall in this particular scheme. Lastly, if I take this is the TCO calculation, and we will be studying in detail about and discussing in our further webinar on this both schemes. Lastly, just wanted to touch upon the TCO also. So what is the cost of production of green hydrogen? So here we have attempted the TCO, and all these costs are in INR per kg. And this TCO has been formulated for a 1 megawatt PEM electrolyzer, which roughly has the hydrogen plant cost of 11 crores, out of which the stack cost is forming around 70%. And here the hydrogen production efficiency, which is for this 1 megawatt plant, is 22.5 kg of hydrogen per hour. So yeah, and again the efficiency is we have taken is 55 kWh per kg of hydrogen, and this cost are calculated for the renewable cost of 3 4 rupees per kWh. So all this cost you can see for the RE cost of 4 rupees per kWh, and then we have formulated the scenario later on, like if my RE cost is decreasing, then how is it impacting my overall hydrogen cost. So as you can see here, the capex, if we see out of the overall TCO, is roughly formulating a 1/3 of the cost. So yeah, and out of that also the hydrogen generation plant cost is 25%, followed by later cost, which is land, transformer, and the other cost. And if we take into account the OPEX cost, so yeah, the power cost is obviously very high, but also in which is in overall TCO, if we see the power cost is formulating around 53%, and this means it has a lot of dependency on RE, and therefore we have formulated again the scenario with the RE cost and how that sensitivity is. So yeah, so this is overall the OPEX cost, and this is without subsidy. But if we account for the two subsidies which we have previously discussed, which is subsidy one on the electrolyzer manufacturing, and yeah, we again don't know how much subsidy will pass from the electrolyzer manufacturer to the operator, but we have accounted for the overall cost there, and it is like having very minimal impact of 4-5 rupees per kWh. And then after, if we see, if we also account for the second component, which was on the green hydrogen production subsidy, which is 50 rupees at the first year, which was 50 rupees per kg of hydrogen, it was then falling to 357. So if we account like overall with subsidy, then our cost is falling to 357. So this is how the impact of subsidy we can look like, and this is for the PEM electrolyzer. We have also some numbers for the alkaline, where we can see because of the alkaline electrolyzer less, we can see the less TCO because of the impact of the alkaline electrolyzer stack cost. Yeah, and then how my sensitivity is around the RE cost, that also we tried to analyze, and what we have understood that with the 4 rupees per kWh, I can obviously get, like, there are the high cost, but as I'm reducing my RE cost, so I will get the reduced uh, yeah, reduced TCO. So, and the impact is almost like 70 to 80 uh, 80 rupees, which is around $1 per kgh2. If we see for 4 rupees per k, if my RE cost is 4 rupees per kWh, then without subsidy I have the TCO of 410. But if that RE is going to 2.5 rupees per kWh, that TCO will go directly to 330 rupees per kgh2. So this is how it has a exponential impact on. And yeah, again with the subsidy, as we have understood that electrolyzer subsidy has the minimal impact with, but the green production subsidy has. Yeah, so this is how we have accounted for the TCO also. And now we look forward to the discussion of how both this component, which is scheme 1 and scheme 2, can have the overall impact, and in our further discussion. So I request Rahul to take it. Hello.
Thank you very much, Saili, for a good presentation. I think for the audience, it helps to understand that green hydrogen space is kind of growing globally. India is taking a share of almost 5% of the global green market, green hydrogen by its consumptions. Of course, like if we start doing better and exporting a lot of green hydrogen to the world, then from the broader market, India can take a leadership role in terms of taking its market size on the global level. And we also talked about the TCO economics. I think we'll delve into a little deeper. So let me start first with you, Kiran. We talked about PEM electrolyzer. So before we go into a little details, Kiran, like I may not have done the justice to introduce your work at Plug Power. So if you can briefly introduce the work that your company is doing in PEM electrolyzer space globally and in India. So that will set up a right context for next further discussions, Kiran.
Yeah, sure. Thank you. Thanks, Rahul, and thanks, Ali, for the great presentation. I think Plug differentiates itself in the hydrogen market, not because it is not a simple OEM or an equipment provider. So Plug has been in the hydrogen space for last 20 plus years and has been in the business of creating hydrogen demand. So it's more, so we have to think from that perspective. So apart from the industrial segment where hydrogen is used, so Plug successfully commercialized hydrogen fuel cells for a commercial application. So we have successfully used the fuel cells in replacing batteries in the forklift truck space. That in turn, because we wanted to solve the problem for hydrogen, solve the problem for the customers and make hydrogen adoption easy for the customers, Plug has also been supplying hydrogen, setting up liquid storage plants at customer locations, even setting up hydrogen refueling stations. So owning the whole solution, not just simply selling the fuel cells or one part of the solution. So I think that gave Plug a unique insight into the operations of hydrogen. I mean, for example, we do about 50,000 refuelings every day. So every day, so 50,000 times hydrogen is getting refueled. So yeah, there are concerns. I mean, in general, whenever we say hydrogen, there are a lot of concerns. Yes, there are concerns, but just like any other fuel, there should be standards, codes, safety, and equipment certification, which will take care of it. I'm not saying it is easy. Hydrogen is very, very challenging. As I read more and more about hydrogen, I realize that there are many challenges that we need to figure out while we mass adopt hydrogen as a replacement for fossil fuels. So with that background, Plug obviously uses the PEM fuel cells because PEM fuel cells are most suitable for mobile applications. So you can start, you can stop, and all that. I mean, I worked in the solid oxide space. The biggest challenge I saw that they needed to run continuously in order to get the best efficiency, best life, right? So that was the main challenge on solid oxide. So I felt that PEM has a better advantage because you can start and stop much more easily compared to solid oxide. Now, from that space, why Plug moved into electrolyzers is because customers started showing preference for green hydrogen. Now, so customers said, okay, green hydrogen is available at a certain cost, which is comparable to gray hydrogen. So they would be willing or pay premium to that. So then Plug looked at what all solutions are available for green hydrogen and selected PEM electrolyzer as the right solution, which has sufficient maturity and also in terms of simplicity, in terms of installation and operation. So that is how Plug acquired a company called Gyner, and along with Gyner, Plug acquired a system integrator, a cryogenic storage company, a liquefaction company, and even the hydrogen tankers or trailers, so that you can transport liquid hydrogen across the geography in US. So we now have an end-to-end offering, And this end-to-end offering is not because of anything else, but because of our desire to serve the customer, provide a complete solution to the customer. Now, as we are also now setting up our own hydrogen production plants in US. So currently a 15 tons per day project is under installation, nearing commission, and we have plans to reach 70 tons per day by end of this year, and ambitions to reach up to 250 tons per day and ultimately reach at least 500 tons per day by 2030. So they are huge numbers. We are talking about gigawatts of electrolyzer. So when Plug selected Gainer's PEM electrolyzer, I mean, they looked at what technology can they scale, what technology can they use, and that is how they selected, even though they looked at all other technologies available. So that's the background of Plug. And Plug has a joint venture now with Renault in Europe to do hydrogen mini buses and delivery vans. Similarly, we have a joint venture with SK Group for Korea market. Other than that, we are working with many renewable energy players. Recently, we have agreed to supply a megawatt scale storage to a company called Gravity. Gravity uses gravity as a storage solution. So even they felt that PEM fuel cells are a good solution to in terms of energy density and also the maturity of the product. And it is also approved by the commission to replace diesel gensets. When forest fires happen, they were using diesel sets. So instead of storage, they felt, okay, PEM fuel cell could be a good solution. So there are multiple things happening. In fact, one of the aeroplane that flew with hydrogen, they had engine on one side and other side was a fuel cell. That fuel cell was supplied by Plug. So Plug is kind of totally committed to hydrogen as a future fuel, and working on multiple fronts, including having a team of 150 engineers in India for global engineering. So I'll take a pause there, and if you have any question, then I will expand on that.
Thank you very much, Kiran. So let me come to Vishwanathan. Vishwanathan, like I know you have focused on RE and now focusing on alkaline and fairly close to taking it to commercialization. So what are the product lines that Ransol Power is supporting, and what opportunities you see when you have bet on alkaline electrolyzer technology over PEM? Oh, you are on mute, Vishwanathan. Vishwanathan, we cannot hear you.
Sorry, is it okay now?
Yeah, we can hear you now. Go ahead, please.
Yeah, thank you. So good afternoon to all the panelists, and very impressive story by Kiran. We didn't know the total scope of operation of Plug, and we are very glad to know about this. You are making awareness of hydrogen very, I can say, intensively around the world. And coming to our background, Ransol Power Private Limited is a company. We are a channel partner of Bosch, and we have been into megawatt scale power plants and solar projects for the last 14 years in India. And as a collaboration, we have also been working with IIT Madras, Dr. Reddy of HCTP Mechanical Engineering Department for making concentrating solar for power for thermal solar energy and all that. So this is the background of our solar story, and because of our experience with handling high currents and DC engineering, etc., in solar energy in megawatt scale, we decided to get into the development of high voltage, high current, low voltage DC control systems, and we partnered with ARCA Hyderabad for developing it for their methanol fuel cell, methanol electrolyzer, and it has been successfully tested. And with that background, we started into R&D for making indigenous electrolyzer about 3 years back. And we have successfully developed the cell, which is the most important component of the whole stack. And then we are now making a commercial scale stack, which is going to probably match with the volume of production requirement on a pilot plant of, say, about 500 kilowatt, etc. And on the performance side and on the engineering side, what the journey we got through was a lot of learning to do with materials connected with the electrodes, as well as the chemistry of the electrolyte which is to be used in the cell. All this has been a very good learning, and we now feel deeply confident to make an indigenous electrolyzer for Indian conditions, because here we have various scenarios which we have to deal with in actual commercial scale operation as well as industrial scale operation. And most importantly, what is required is the backup service as far as Indian customer is concerned. We are a supplier of battery chargers to Indian Railways, and we know the problems which come if you don't have backup service for any equipment you supply here. So with that in mind, we engineered this machine, and we are also focusing on a model of manufacturing which can be on automobile scale, so that if you want to make in volumes, it should be machine producible and assembly should be easier. So that kind of approach we have taken, and fortunately we have very good people to guide us also, who are PhDs in electrochemistry, etc., who are across the table sitting with us and helping us make the right moves. Conceptually, if you see alkaline electrolysers, it's been around for more than 50-60 years in India, because it's part of the chlor-alkali industry story. So all the chlor-alkali business in India is happening only on the alkaline electrolysers. I'm sure Dr. Arvind would endorse what I'm saying. Am I correct, sir? Yeah. So with that kind of proven technology path which has worked for the Indian climatic conditions as well as availability of raw materials and all these factors, and the scope to reduce cost, that is also another important factor as far as Indian industry outlook is concerned. They are always very concerned about the price factor. So we have been into dealing with industries last 15 years, supplying the various equipment, so we understand the mindset. And overall, finally, the ROI is what matters. Nobody cares in what machine you make the hydrogen. Finally, they see at what cost it comes. So at the end of the day, that's the story which sells here. So we are hopefully we'll be able to put up our pilot plan shortly, and we'll assess the cost to a more accurate number at that point of time.
Sure,
Incidentally, what we are trying to do is we are trying to make the electrolyzer compatible with renewable energy vagaries, because even if there is a variation in the availability of power, it should perform over a bandwidth of percentage of power availability between say 50 to 80%. That is the kind of technology we are trying to bring in. Because of our experience in DC engineering, we are confident it will work like that. So this is the kind of picture which we are looking at, Rahulji.
Sure, sure. Thank you. Thank you very much. And just to summarize, Vishwanathan, like you have developed indigenous alkaline cells, and now you are working on putting up a commercial stack. And is that of a 500 kilowatt stack pilot that you will be doing, or that will be of smaller size?
No, this can go to megawatt scale. Like I told you, we are people who are working in megawatt scale power plants only in solar. So we are looking at making a a pilot plant which can be scaled up in modularized way. Like in solar, what we do is we put panels together and make a megawatt scale. So same way we want to put stacks together to make it a megawatt scale.
Sure, Vishwanath. And just curiosity, like if someone puts an order of 1 megawatt alkaline electrolyzer today, what is the ability to produce? What's the time lead that we are talking to have a fully operational plant running?
Once our pilot plant is successfully commissioned and it is tried out, we will be able to give you a more definite answer. But we are working on perhaps a time scale of turnaround within a maybe around 6 months time from the time the order is placed to put up a plant, because that's the kind of speed which is required to make commercially viable project here right now.
Okay. That's good to keep in mind. Thank you, Vishwanathan. Coming to you, Arvind, like I think you have heard both panelists kind of representing two different technologies. What is your take on between the two technologies, suitability for Indian conditions, and what are the important drivers you think that will lead to improvement in the technologies, the performance, both the cost and the operating performance, Arvind? You are mute, Arvind. You are still mute. We cannot hear you, Arvind. Can you unmute yourself? Below the orange arrow, there is a mute unmute button, Arvind.
No, he seems to be unmuted, but yeah, now it is unmute. Can you try now?
No, we cannot hear you, Arvind. No, Arvind, we cannot hear you.
On the in the control panel, there is audio. Maybe you have to check the right microphone. Maybe what did you select?
I thought I heard you, Arvind, like initially when you joined, right? No.
Yes, he was audible, but now he's not.
Maybe quickly try rejoining, possibly. That should solve.
Yeah. Arvind, in the meantime, while you are trying, as soon as you are able to get back, let us know. I will, in the meantime, try to understand with the other panelists and come back to the same question back to you, Arvind. Uh, uh, Kiran, coming back to you, Kiran, like what are the important considerations once the PEM technology electrolyzer is placed, Kiran? Like what are the key trade-offs in terms of the design, in terms of the performance, in terms of the cost uh, that can be looked into from the PEM electrolyzer technology, Kiran? And just as a reference, I think for all of us, like if we can keep a 1 megawatt kind of a thing in common in our discussion, it becomes easier for everyone to understand with reference to 1 megawatt.
Yeah, I think when I started at Plug, 1 megawatt was the most popular one. There all the inquiries for 1 megawatt. By the end
Now
of
it's
20,
5 megawatt.
yeah, so 1 megawatt became 5 megawatts. So
Yeah,
right
yeah.
now, sometime in either 2022 or early 2023, let's check if Arvind is able to speak.
No, Arvind, we cannot hear you. Nope.
Maybe join from a different device, possibly. Okay, so
Yeah,
while it
let's
is trying, so what I said is the trend has shifted to 5 megawatts. Okay, in fact,
yeah.
currently we have 5 megawatt under installation for NTPC at Vindhyachal. So 5 megawatt became the standard for demonstrations. So where a customer just wants to understand whether how difficult or how complex is hydrogen production and just want to experiment whether they can use hydrogen in their process or not. So they are still looking at 1 megawatt. But whoever has a little bit of confidence, but they feel that the cost is high, but want to start adopting hydrogen, they have already shifted to 5 megawatts things. Obviously, the serious projects are in multi-megawatt. We have, I think, a 120 megawatt single plant also on order. So various sizes are in order. So they're all much bigger ones. But this year, I think we'll mostly see a majority of 5 megawatt deliveries happening from Plug, mostly either in US and European markets. India, as I said, we have 1 5 megawatt getting installed. I think maybe by towards the last quarter of this year, that means the fourth calendar quarter, we should be able to visit. I don't know if NTPC allows, but we should be able to visit the 5 megawatt and see the performance. But I mean, in terms of if you think about the both alkaline and PEM, alkaline has obviously has been around for a long duration, and therefore there is generally more experience. But again, PEM has been around for a similar longer duration, but at a much smaller scale. So the Gainer, the company that we had Plug acquired, they were supplying electrolyzers to submarines, and space station, and other those kind of critical applications. So they were these stacks have been in operation, but pretty small ones, kilowatt size. So the scaling up to megawatt size is happening now. So now the building block of plug is a 1 megawatt stack. The stack itself is 1 megawatt. So 5 megawatt electrolyzer will have 5 stacks. Similarly, the next generation is already looking at 2 megawatt and 5 megawatt stacks. Why that is critical is, I definitely like modularity because Bloom fuel cell was very modular, so it provided resilience in terms of one fails, you have still the rest of the system working all. But I think when we are talking about gigawatts kind of scale or about 100 megawatts of scale, the stack size, the building block itself needs to be of a reasonable size. So that becomes also important. Modularity is important, but I think too many small components will make the whole system very complex. So that is one point I thought I can emphasize. Other than that, see, between AM, alkaline and PEM, the general expectation or experience is alkaline has been around for some time, so the technology is mature. So therefore, the cost reduction possibilities under alkaline are estimated anywhere between 15 to 35%. On the other hand, PEM, it has been very small, so therefore there is more chances to scale up and more innovation to happen. So therefore, a cost reduction of 35 to 55% is expected in the same period by 2030. I can share the study that mentions this so that you can quote, if you are publishing something, you can use that. Similar, I think what are the key reasons? One is the manufacturing capacity itself. So right now we have already got our gigafactory in operation. Earlier, the megawatt scale stack was hand assembled. Now it is all machine assembled. So our monthly capacity is 100 megawatt per month. So you can understand that the scale benefit will come there. Similarly, the first gigafactory would have costed a certain amount of money and a certain amount of space, but the expansion from 1 gigawatt to 2 gigawatt will not have similar cost or similar time. So we can do it in less than a year and a fraction of the cost for the first gigawatt. So the bigger the factory, the lower the overheads and automatically the loading on the individual stack. The second aspect is the standardization. Now, till now, the customers will ask, they have a specification, they have a customization, so it adds to time, it adds to resources and all. As we move forward, I think at least our 1 megawatt and 5 megawatt are containerized systems. So they are standardized. So the standardized means it becomes more easy to manufacture and fabricate them at scale. That will lead to another set of cost reduction possibilities. Similarly, there is generally a concern that PEM requires rare earth materials, rare elements and all. But I think there is a lot of research going on to reduce the quantity of rare metals in the electrolyzer. Second, increase the efficiency of the equipment. And lastly, recycling of this rare metals is going to happen in a very closed circuit model. So once the electrolyzer goes below the accepted level of, say, efficiency, then I think the recycling will ensure that the metal is brought back again into production. And because the amount of quantity per megawatt is going to go down, a megawatt retired from now in 10 years might be able to support more megawatts of the metal required. So that way, I think, yes, there are concerns, but I think they are being addressed. Everyone is working on them. So these are few points I thought I can add. Arvind seems to have come back. Can we try him? He's not on video, that's all.
Let's try that. Hi, Arvind. Can you? Wonderful. We can hear you now, Arvind.
Oh, could you hear me?
Yeah. Now we can hear you. We cannot see you, but that's better. We can continue.
Oh, okay. Now I don't know what has happened. I'm very sorry about that, Rahul, Kiran, and Vishwanathan. I'm very sorry.
Great, thanks.
Yeah. So I've been listening to Kiran and also Mr. Vishwanathan. So if I can answer this question about PEM or alkaline, my answer would be we need both actually, Rahul, because the requirements are in fact fairly large. In fact, the kind of gigawatt scale requirement that we have, it's not that one technology can meet both the requirements from the manufacturing side of it, and also from the operational side and the cost side of it. At the moment, it looks like alkaline seem to be fairly cheaper, right? But then other side, there are some performance requirements. For example, if someone wants to work on grid balancing or vehicle applications, or let's say you wanted to suddenly turn on and off, I think only PEM electrolyzer can be so dynamic. For example, we typically in India, the duck curve that we typically talk about, in the evening, suddenly the power requirements go up, eventually grids have to meet that sudden crank up of the power. So, and then there is sudden hiccups here and there. Can we really go with PEM system for that kind of application? The answer is yes. I think alkalines, like the start and stop time is fairly large, so that's where I feel the PEM will take an edge over alkaline. But on the other side, what I feel is that alkaline, we will have our own India's technology, because we don't have to rely on imports for many of the components. It's predominantly nickel based ones, right? And there are many companies which are in fact making it. So one is that if any geopolitical issues, for example, has to come into the play, alkaline might take a hit, whereas PEM might take a hit, whereas alkaline will not, because it's about predominantly nickel, I think, right? Essentially, it's all about nickel that we're using there. So, but being said that, it's very difficult to say which one will take edge over others. Like one will be more prominent than the second one. In terms of operation side, alkaline will be used for a lot of industrial applications, whereas PEM-based systems will be used for very dynamic requirement system applications, right? And in terms of manufacturing side, I think alkaline, India will have a definite edge over others in terms of because we have resources in-house, whereas PEM, we might have to really think about it, where it's going to go. That's where I feel both these technologies do stand in the hydrogen scenario.
Sure. Thank you,
What
Arvind.
about the water purity factor, Arvind? Arvind, I'm asking a question. What about the water purity factor?
Okay. I think that is. I think if we go technically, I think we will have issues also. So, I mean, of course, there are like many devices in operation, both in PEM as well as alkaline side. I mean, we have so many devices and several hundreds of thousands of hours of operations have been recorded for many of the devices. And in fact, both the devices have shown phenomenal performance. But I think you rightly pointed out, when it comes to one of your points that you mentioned, when it comes to the actual Indian operation scenario at a very large scale, mistakes tend to happen in terms of water purity. Like not all the water purifiers will work at generating like a really ultra demineralized water, right? There are some sort of impurities might come in, and those small impurities might affect the catalyst over time. That is something that we need to really work on. And the answer, I would say, at the moment is it's blank and gray. Until we operate in our own conditions, we will not be able to comment on what is going to be a hit on the water purity side. Being said that, the water purification stations nowadays come with the PEM electrolyzers, also with alkaline electrolyzers. Majority of the companies also supply the balance of plants along with the electrolyzer itself. So meaning they already know that water purification plants are going to provide the necessary purity for their electrolyzers. So if at all our Indian operation scenario is going to take a hit if companies doesn't provide the water purification unit, then it's going to be the electrolyzer. If companies provide the water purification unit as a part of their system, then even with the bad waters, only the water purification systems are going to take a hit, but not the electrolyzers as it is, I believe so. So, and the next concern that we have is the pH at which we operate. That is something we also have to look into. Maybe I'll take a pass here and I'll let Rahul continue with the questions and further discussions. We can discuss more as we go along. Thank you.
Sure. Thank you very much, Arvind. Vishwanathan, coming back to you, like there are discussions in the electrolyzer manufacturing, they call it as a performance core, which is looking into the specific fuel consumption, kilowatt hour of electricity RE used per kg of hydrogen production, right? So can you guide us and discuss like what are the internal design considerations in alkaline technology which influence SFC, which is kind of stated in the range of 46 to 55 kilowatt hour per kg. Where do you think your current development stands in terms of the SFC consumption? And in future developments, what it can go low? So just trying to understand what drivers drive SFC and what is the roadmap for alkaline electrolyzer, Vishwanathan?
Yeah, thank you for the nice question, Rahul. As of now, what we have understood from the baby tests and lab kind of experiments we have done is Presently, anything around 55 to 60 is the kilowatt hour consumption, which can happen in a basic scenario of alkaline electrolyzer. The most important thing is, which is going to bring this down, is going to be the electrode material behavior and also the electrolyte which we are going to use, because obviously we cannot use just a plain but a KOAH or something like that, which can just do the function of ion conduction. We need to add a catalyst, and that is the critical area where we are also working now with some experienced people. I am sure Arvindji will accept with my point of view. So that is precisely the element which is going to define how more efficient your electrolyzers can be. And also there is a lot of problem with the corrosion of the electrodes themselves, which are put in the test cycle for a period of time, and that has to be very good metallurgy, has to be reliably there in the electrodes in order to withstand the duty cycle. As the current goes up, the performance dynamically takes a lot of pressure on itself to perform. So talking about higher currents like 1000 amperes, etc., and that kind of running currents on a duty cycle, a lot of engineering has to go on the DC side. It's more in fact on the DC engineering rather than anything else. Whether it is a PEM or whether it is alkaline, that is going to matter. The engineering part of how we handle the current path and everything. So overall, if you see, I think anything between 50 to 55 should be very acceptable to the industry. As of today, 46 and all, I think is perhaps a textbook benchmark. I don't know what Arvind will say about that, but as a professor, he will know more to talk about these areas. We are practical engineers who do projects, so we confine ourselves to the guidance from our consultants, and we move on with our own experience. And material choice plays a big role here. That is what I would like to say.
Sure. Thank you, Arvind. Vishwanathan. Just for everyone's attention, like the performance score highlighted in electrolyzer manufacturing, I was just looking. The maximum is said 56 kilowatt hour per kg. So anything above that is not acceptable. So it definitely has to be lower. Kiran, you would have any point of view to add?
Let me clarify what the PLI is talking about, the stack level, not the system level.
We are all talking about stack level, Kiran, here, because ultimately the DC part is.
No, what Rahul is referring to is to the PLI document. So that 56 is talking about the PLI document. So what you are saying is at the system level. I also am talking about the system level, but I am saying what Rahul is referring is the stack level. So stack level will be lower, Rahul. So
okay.
So I know that at least my precursory look at that document, I felt that we might qualify for the highest incentive. So that is not a challenge. I think MNRE has put it in a more practical manner. I think they would have collected the information from various manufacturers and accordingly set the limits. So I don't know if you have seen it, Mr. Murali. Maybe if you take a look, you will understand what I'm saying.
Thank you.
So what is this? What is this number that with current technology plug solution is able to support at stack level, Kiran?
I don't have the exact number, but as Mr. Murali said, depending on what is the current density, what is the operating level, right? So the efficiency can go anywhere between 55 to 57 at the beginning of life, and there is also a degradation over a period of time, right? So there will be around 4 to 5 kilowatt hours increase over the degradation period overall. Okay. So, but I think, as I said, when I looked at those numbers, I felt that we will qualify for the highest incentive if we happen to apply for that.
Sure. And Kiran, are you very sure that the PLI is asking at a stack level?
Okay. Yeah, it is. It is. I maybe will find the document and read that statement, but you can continue meanwhile.
Okay, sure. Arvind, you want to add anything like what drivers between these two technologies will drive the SFC, because that's an important metric. Like in TCO also we saw that SFC is forming almost greater than 50% of the overall cost. So what drivers across this technology? Is it materials? which will have a prime significance? Is it the DC design, which Vishwanathan was saying, like how to handle big currents? What will play a major role, and where do we stand, Arvind, with that?
So, Rahul, I'm going to just slightly take a step back and look things holistically. If you look at the overall cost of hydrogen, and Shayali made a nice presentation on where the entire hydrogen cost comes from, right? It is the renewable electricity, renewable electricity. And the thing is that, the number 111 that people always talk about, $1 per kg in a decade, and it looks like completely a nightmare number to me. Honestly, I think somehow we need 55 kilowatt hour per kg of hydrogen generation, and even if we take 2 rupees per unit, that already comes to 110 rupees, and which is already more than $1. And then the capex investments, water cost, everything else. Let me keeping that aside. I have a strong feeling we should target 211. That seemed to be fairly reasonable to target. I think maybe in this webinar, let's take that as a number to our mind. I think let's not get biased by the newspaper numbers or some I don't know. I'm in a neutral area. I can talk actually. Companies cannot talk openly, but I can talk. I think we can take a neutral view, irrespective of what company says what. If you put logically, imagine people talk about reducing the total energy consumption from a PEM or alkaline, which takes around 50, 55, 56 kilowatt hour per kg of hydrogen, to SOEC, which takes like 40. Even if it is 40 kilowatt hour per kg of hydrogen, still we cannot get to $1, honestly. So my strong, and now the nitty-gritty is like comes here, and we talk about green hydrogen, right? Green hydrogen. And are we going to operate the electrolyzer only when there is renewable electricity available? Because our banking time needs to be discussed extensively, right? Are we going to give banking time of 12 hours in the grid? Then I think people can operate the electrolyzer 24/7, and then the cost per kg of hydrogen will go down. Assume if we have to go for all standalone, no grid connected, only renewable power, then we have to include the cost of energy storage. And once that come in, the overall cost of hydrogen is going to crank up like anything. Sometimes I have a feeling let's accept where the problem is. I'm sure there are a lot of good participants here, and our eminent panelists are also discussing all these things. If you look at holistically the whole system, the cost is not going to come from materials. They're going to save a bit, definitely. The capex side is going to be definitely saving, no doubt about it. But that's not going to save the cost of renewable hydrogen so much. It's about the renewable electricity at the end of the day, and we have to really, the companies and like yourself and Plug Power and Rensol have to really work around the policy with the government to try to see how to make the entire renewable electricity go down significantly without energy storage, but with a larger backing time. That's going to really create a big impact in the whole the costing that you're talking about in the hydrogen scenario, Rahul.
Sure, Arvind. Thank you. Saili, if I may request, if you can move to the TCO slide, just while everyone can refer to that discussion. Kiran, coming to you, because that I know you have your hands up, Kiran, and I would want you to speak. But in your discussion, if you can also include, Kiran, like you come from utility background, RE side as well. What is a full 24-hour cycle that you see in Indian context that is possible, Kiran? Like when we are talking of green hydrogen, irrespective of technology, feel free to talk of PEM technology, but how will you ensure that right utilization of the asset? What Arvind is trying to raise, like with renewable limitations, either solar or right wind combination. So what's your thought on the overall systems? Like what do you think is an ideal system to run in Indian context? 5 megawatt is a unit that we can now assume.
Doesn't matter. I just want to first clarify, read the statement from the policy that we discussed earlier. It says specific energy consumption to be equal to or less than 56 kWh per kg of hydrogen production. For this purpose, the SEC shall be measured at 100% rated capacity at the stack level on DC side.
Okay.
That settles, I think, right? Okay, so that since we are read on that side, now let me come to the arguments of whether $1 is realistic or not. Second, what is the current scenario, what will be the future scenario, right? How this hydrogen will evolve ultimately. Because if you think about hydrogen as an energy carrier, we all know that though we know that electricity is a major energy carrier right now, it is only supplying 20% of energy being consumed. Rest of 80% is coming from either gaseous, solid, or liquid fuels. So hydrogen is actually competing with those fuels, number one. So that's the important. So that means there is an 80% opportunity. Assuming electricity will double, still 60% needs to be met through alternate non-fossil energy resources, and hydrogen could be one of the main sources, right? Either directly or indirectly through hydrogen derived products, whichever way, right? So the efficiency argument is highly relevant today because the power prices are high. Now, in the future, as the electricity prices, we all know everyone is still talking about solar prices going down further and wind prices going down further, because till now offshore wind has been a very, very small component. So it is expensive. So even wind adoption in India has been lagging significantly in the last 5-10 years. It has to pick up. Similarly, solar last 2-3 years we have seen that it did not pick up. Now MNRE and government are talking about at least 50 gigawatt per year. And recently IRENA mentioned about 1000 gigawatt of renewable energy across the world to be installed if we want to stay within 1.5 degrees, right? So with this in mind, the cost of electricity has to go down or will go down because of the scaling. Now, as the scaling happens, the efficiency benefit will also start diminishing. So we have to keep that in mind. So rest of the other parameters will start taking importance, right? And second, the ability to use electrolyzer as a grid balancing will come into picture when we have a lot of excess renewables and the electrolyzer cost also goes down significantly. So the future targets of say $250 per kilowatt or $400 per kilowatt kind of electrolyzer cost, those are the numbers that will be able to support the grid balancing kind of thing. So you can operate like 10% to 20% of the time where there is excess, convert it to hydrogen. Need not convert it back to electricity. Actually, you can, because you need a lot of gaseous and liquid fuel. So from that ultimate scenario, the efficiency has a limited role. If you ask me personally, the first 5 years there will be a lot of focus on efficiency. But I think as we move forward and the cost goes down, the efficiency becomes a secondary factor, and the cost of electrolyzer start increasing in its importance. Okay. For the time being, yes, banking seems very nice on paper at central government level, but when we come down to the state and DISCOM level, it is a challenge. It is really a challenge. I'm telling you, DISCOMs suffer on all possible sides. Okay, so they suffer from customer side, they suffer from government side, they suffer from policy side, right, and even performance, because no one really understands what challenges DISCOMs go through. So one of the at least only silver lining in the whole policy is at least MNRE created a position saying that DISCOMs can also be a part of the hydrogen value chain or hydrogen ecosystem. They can also sign an agreement with the hydrogen developer and provide the banking facility. I mean, see, there were arguments about, oh, banking will increase the emissions of hydrogen and all those kind of things, right? Yeah. I mean, if you do a extremely rigorous, very idealistic kind of calculation, banking will definitely add to the emissions of hydrogen production, no doubt about it. Because if solar and wind are available maximum 40% or 50% a year, rest of the time you are dependent on coal. We are 70% coal, right? So therefore, that emissions, if you add hour to hour or minute to minute, it will look like a very high emissions, right? So, but if hydrogen has to grow, right now the argument is not take hydrogen and do everything, but take hydrogen and replace gray hydrogen to begin with. For India, the argument is gray hydrogen is imported. So we are spending a ton of foreign exchange and we are exposed to foreign price variations. We are exposed to forex variations. So we have a lot of risk on that. Recently, I mean, last year, I remember GAIL purchased one lot at $40 per MMBTU, right? So there is a lot of risk. So green hydrogen is an extension of solar. Solar provided a price, kind of fixed price for a long duration for us, right? Unlike oil, coal and solar, which are produced within our country, we have certain amount of price fixation for a longer period of time. So green hydrogen extends that benefit from solar electricity to hydrogen as a liquid or gaseous fuel. So that is one benefit. So, and second, even in case of any supply chain disruptions and all, if we are producing hydrogen, it stays within our country. No one can come and stop solar or wind, so our hydrogen supply will still be available. So even from that perspective, hydrogen is valuable. So while there could be a very puristic perspective, say, oh, banking will increase the emissions, we have to develop the hydrogen sector. If we say we will wait till grid is decarbonized, we will never understand hydrogen. We will lose the opportunity to understand hydrogen, and we will either have to be a technology taker or a solution taker. We'll be importing hydrogen equipment, we'll be importing solutions, we'll be doing everything. So Atmanirbhar Bharat is gone. The Bharat Pe Nirbhar is a new slogan. So that means we not only are okay to import what is necessary, but also we are willing to export. We are looking to export. So right, while this domestic manufacturing is a good thinking, we should not think that trade is bad. Trade is very important. That is how the technology comes to a country, right? That is how we can leverage on our strength. So there are some strengths we need to leverage. At the same time, we should not be closing the doors and say, oh, anything imported is bad. It's not like that. As long as there is a mutual respect in the trade, I think that is beneficial, mutually beneficial to everyone. So I know I've gone a little here and there, but broadly my position is banking is okay in the short term. Slowly and steadily, we should move to hybrid. And even storage will play a role in hydrogen to some extent at still certain point. But beyond that, hydrogen and grid will work like a hand in hand brothers, right? So one will support other will support this. So that is ultimate scenario in my mind.
Sure. Kiran, would you know like how MNRE intends to measure the claim of green hydrogen production in the second scheme, where it is saying that per production unit some 55 and gradually reduce to a lower number? How with the variability of the RE, so will it be measured and being paid only for those time where RE went into the plant? So is that the kind of accounting that will go in? Any thoughts on that?
I think, see, they have to publish the clean hydrogen standard. I don't know if it will be called green hydrogen standard or green hydrogen standard in India. But we already have a policy from Ministry of Power last year, right? February. That was the first policy that came on 17 February 2022. So that is the most daring step the government of India has taken. And I don't think any other country has done that kind of thing, where they waived interstate transmission charges. They said green hydrogen production electricity can be considered for RPO, and they also provided for 30-day banking. So that is also similar to what position Europe has taken in terms of matching the production of renewable energy and hydrogen production. So I think the 30-day banking is what I expect MNRE to use, not to do a hourly or 15-minute matching at this given point. Our market is not developed yet to that extent, and we need hydrogen experience, because if more and more people in India are experienced on hydrogen, we can innovate, we can find new applications, we can advance technologies, right? We can reduce costs, we can reduce complexities. So therefore, we need to have this electrolyzed hydrogen production kick-started in India, and not wait for the world to advance and reduce cost and then think that we will simply import the technology. So therefore, it is important to provide this support to hydrogen, just like the support was provided to solar rooftop, for example. Without net banking, solar rooftop would not have happened. Whatever has happened, it would have been zero simply. So as a utility, I know. Yeah.
So 1 megawatt of stack, Kiran, like what kind of connection using open access banking or others you are suggesting, which can make me run electrolyzer 24 hours cycle? Is that possible, or we should plan for a capacity utilization of 55 to 65% or 70% of electrolyzer, assuming downtime of the RE? So how to look into that system level design for maximum green hydrogen production? Both basically Vishwanathan and Kiran, if you can very quickly, like we are running close to the time, I would want to take some good questions that are coming from the audience.
Yeah, I'll just take 1 minute, intervention in this conversation. There is some clarity lacking on the green hydrogen label being given to hydrogen, which is manufactured using banking of power, because this issue was touched in our Germany visit at Belgium, Rahul. I think you may be remembering it, but I stored it in my memory because I am in the power game, and to me that was very important points to consider. So what I understood is that they are not allowing you to use banked power and consider it as a green power from which green hydrogen is made. Of course, we don't care about Germany. Let's care about India only. Even then, this element of consideration is there. Another factor is most of the state discoms with which we are operating presently in Tamil Nadu and Andhra Pradesh, we are running megawatt scale power plants. Both of them have pulled out this banking and made us bone dry. Okay. So practically, we have lost all the initiative and interest we had in originally for the investment, and all our investment, our principles have been, I can say, disappointed because the government has changed its policy at its convenience, and therefore it's a kind of very difficult terrain to predict the 25-year durability of this promise being given by MNRE and any other agency, because state governments do their own policy and work on their own way. For example, in Andhra Pradesh, Kiran may be aware, the chief minister is willing to go to court rather than accommodate the investors' expectations, right? From 4 rupees 26 paisa something per unit, it is now 2 rupees 48 paisa, and the wind power producers have nowhere to go but to the court. So this is the picture which is a reality which we all have to deal with from investment risk perspective. Therefore, totally banking on banked power and that driving your green energy and green hydrogen, etc., would be a commercial risk also to take, in my opinion. So I would very much align with Arvind ji's suggestion of probably going for a hybrid mode renewable energy at site, along with storage, which can probably give a smooth DC power line for the production of the hydrogen. That is one factor which we are also thinking seriously, because we are planning to put some kind of hybrid at our site and manage it along with DC bank purification using storage also. So
So
this will
Vishwanath,
ensure,
with captive
yeah,
RE and storage, would you still
captive
run?
RE and solar along with the storage will help you to at least ensure maybe 60% CUF of the electrolyzer investment.
Okay. So the capacity utilization of electrolyzer, even with this captive and solar storage, will be 65%, you are saying, or that's on the design of the
It
solar
all
plant
depends on the
and
design factor. I mean, there are a lot of design aspects to consider, but the ballpark number would be 60%. That is a reliable figure which we have analyzed on paper, but only a trial plant will give us the right, truth of what we are all trying to pronounce as a possibility.
Okay, okay. Let me get back to Arvind. Arvind, on the indigenization, because the scheme has also highlighted clear targets. The minimum indigenization today is expected 40%. If I'm talking of alkaline electrolyzer, right? Even in alkaline electrolyzer, if you kind of take into account just the stack, the cell part, that I assume is almost forming 70% today as well. So if this stack also is coming from outside, then in alkaline also with the current rules, we will not be able to match for the subsidy PLI incentives, Arvind. So what is the roadmap that you see of indigenization of most critical technology, which I say is the stack, for alkaline, and then PEM? Like how many years you envisage that? Because scheme has given 5 years, and by 5th year it is expecting 80% local value addition to happen.
Yeah, thanks, Rahul. In fact, you brought up the most important question, which can reduce the cost of hydrogen. I mean the capex side of it. So by the way, electrolyzer cost is roughly 45%, and on average is a ballpark estimate, and another 55 come from the systems around the electrolyzer. So that's how the split between the electrolyzer and then the systems are. So considering this, I feel like, and then the next part is when you talk about indigenization, it's not just about the cost of the whole system, but rather the requirement that we have, the ambitions that we have on the gigawatts and gigawatts of electrolyzer. If it has to be met, the content has to be indigenized. And like there are many programs that have come up now, where the DST has proposed out a Hydrogen Valley Innovation Cluster, and I believe similar things are also going to come up from MNRE. And everywhere I feel like localized manufacturing. And also, by the way, when I say localized manufacturing, I'm not trying to say that we should not import or something. Localized manufacturing in the sense like, even we can have the technology imported, but let us manufacture with the existing resources within the country. For example, if you can go around any places around Chennai, Pune, Baroda, like there are like a very good engineering small time players who can make any of the components. Ask them to make an end plate, they can fantastically make an end plate. Someone has to be there in order to validate those end plates, for example, and say this is where you stand compared to the benchmark. And India should really focus on validating these small time players, so that companies like Rensol, which is making large stacks, they'll be phenomenally benefited by this, so that they don't have to go and hunt for each of those small time players, for example. And for someone who has a coating for PEM electrolyzer, we need corrosion resistant coating. And India, there are like a lot of MSMEs or micro companies, like or small cottage type of industries, where they do a lot of like this kind of electro deposition. If you can bring them out and do the job, in fact, they can do a proper job. I'm not asking that you have to train them even to do a good job. They are technically very, very sound. All we have to do is that they're doing at certain scale. We have to really push them to move it at a very large scale, plus validation through a proper bodies. It can be academic institute, it can be some sort of centers like ARAI, which is available for automotives, right? If we can have that, that's going to really promote indigenization heavily. We cannot build everything from scratch. We have to use the existing expertise with all the small time players, step onto their expertise and try to scale up to a larger level. And this is going to have a phenomenal impact on the total amount of electrolyzer being manufactured in the country. And also, we are going to delocalize the entire manufacturing. Let's say one place might be manufacturing the end plates, and someone might be manufacturing the bipolar plates, and someone might be making the catalyst coating onto the electrodes. Like we can literally deconvolute the entire activity to the existing experts. Then the cost, that's where the real indigenization happens. Bring the technology from elsewhere, even if it is not available today, and then put them to those real small time experts. Then we don't have a large scale investment or a larger plants also, Rahul. That's going to bring down the cost heavily. And that's one of the key things that we all have to recommend to the country. We always don't have to have like $1 billion plant. We can also promote the small time players. In fact, that's going to reduce the cost phenomenally.
Correct.
That's
where
a good
I the
idea.
word indigenization.
That's
I
a good
totally
idea.
Another small suggestion is that the government can be recommended to reduce the GST on the sale value of the electrolyzer, and also make zero the import duties on the raw materials which we take for manufacturing the electrolyzers in India.
Absolutely.
That's a good point, sir. Yeah.
And what are those items, Vishwanathan, which you will still depend to import for, let's say, your electrolyzer manufacturing, on which you are requesting 0% import duty?
Currently, the
power
membranes have to
electronics?
be imported. Currently, the membrane is not manufactured in India. There is no technologically mature company to make it in scale and also of a reliable product which has been used in the field. So that is one part. Another part is the electrodes materials themselves. So that also is a high technology product. But currently, these have to come from Europe or similar places. So the import duty there is quite high on this. Overall cost addition comes to about 50% on the value of the import at the port level, and due to the GST, etc., it has a rollover effect. So this is one recommendation you can take to the policymakers, Rahulji.
Yeah.
Sure. And what is the current local value of your current plan that you have, Vishwanathan? Like, it has to stand 40% minimum local value addition today. So how much is your local value addition in the plant that you are producing today? And Kiran, I will also come to this question to you also for plug, but just letting Vishwanathan share, like, what is the current local value today?
Current local value addition of 40% is possible. As of now, that is how we are working. In fact, we are working to achieve a little bit more also. So, because ultimately in business, what we have seen, especially in our solar business, which is having very, very thin margins in our for our survival, we know the price plays a huge part, and therefore like I told you, whatever we reduce, every 1 rupee we reduce is 1 rupee 50 paisa here because of the import duty factor. So that is how we have to look at the numbers and try to work. And to my mind, as we see in our approach, what we are doing, 40% local value addition is quite a doable number. But point is, what the government is expecting year on year to go down 10%, 10%, it is some kind of wishful arithmetic. I don't understand how this arithmetic has been done also. Maybe it is just to close the story and the arithmetic, they have given that kind of numbers. We are not able to foresee how that could go down drastically. For every component which you make here, 10% reduction on a yearly basis. It takes its own time to even evaluate what this 40% reduction we have done, whether it works really well. We need minimum 2 to 3 years field service to establish and evaluate your technology is good. Then only we can think of further, tinkering with components and reducing the import content. So that kind of year-on-year reduction principle seems to be, to my mind, not well understood, at least by industry people like us.
Kiran, like what is local value addition in your product today? And do you also have the same question like Vishwanathan and apprehension that it is not doable in next 5 years, reaching from 30 to 70%?
And I'd like to thank Mr. Murali to pointing the round figures and 10% reduction paradigm, right? So, I mean, see, from a policy making perspective, these all look very nice on paper, but the practical challenges are always there, and things happen in steps. They don't happen in a linear manner, right? So, from a PEM electrolyzer perspective, we are talking about the electrolyzer system here, the local value addition. The formula is sale value of electrolyzer minus value of imports divided by sale value of electrolyzer. Okay, so as Arvind said, there are many capabilities apart from the stack that are required in the electrolyzer that can be done in India. Okay, so those evaluations we have been doing, and we are definitely confident of meeting that 40% upfront, and then 80% obviously is a challenge because it has to happen in a particular time period. 80% to achieve 80%, maybe significant some portion of stack also has to be manufactured in India, right? So I think Mr. Murali was talking about 40% of stack in India. At an electrolyzer level, he may be able to achieve a slightly higher local value addition. But a PEM electrolyzer, if Plug brings stack from US to India and does rest of the electrolyzer in India, we might be able to cross the 40-50% easily. But after that, it will become a little challenge. And most important parameter, Rahul, which Arvind and Murali also would agree with me, is local value addition will take pace or take off when there is a clear visibility of domestic demand. Okay, so that is very, very, very critical, and that is one missing component in our mission, in our incentives and all. So we are providing some production electrolyzer manufacturing incentive. We are giving an incentive to buy hydrogen, but there is no demand increase trajectory, right? 50 rupees, 40 rupees, 30 rupees is incentive going down, assuming that the cost of hydrogen production goes down very drastically each year, right? The most missing thing in the Indian policy framework right now is demand creation. And I'll leave it at that.
Sure, and I think this brings a point like the sales value of electrolyzer, that is including only Indian sales, or it can be export sales. It can be just any sales, right? Sale is
only for India. There is India only, India.
They are talking
so
about
it is
50%
only
more sale in India.
Yeah.
51% sale in India.
Incentive is only for India sales, not exports.
Okay, okay. And so I think I get the point that 40% alkaline is doable today. Kiran, you were accepting 40% doable even for PEM. So that's a higher target that you are taking. So it is good. So I think that is a good part. I think, Saili, if you can again move down to the TCO slide, the numbers and subsidies, you all believe that it's too small to kind of contribute anything meaningful. Vishwanathan, you want to share your thoughts? Like there are two schemes we are talking, right? One is for the electrolyzer manufacturing, Vishwanathan, which will come to players like you who are into manufacturing, and the other subsidy of starting with 55 rupees per 50 rupees per kg going below to 30, that will come to actually the producers. So what's your thought on these two schemes? Like one, in terms of numbers which they have given, is that sufficient, good to get the industry excited, or it does not excite you at all, Vishwanath?
thank you for this very important commercial question, Rahulji, because finally
At the end,
everything
you all
rests
have
on
to
the
say, right?
commercial viability of any operation. From what I see as 4,440, it seems to be some kind of, blessed number. That is, I don't know how that was even arrived at, but fine, let us accept it as a choice number. And looking at it from the perspective of manufacturing, etc., on a kilowatt scale, to my mind, it might be a under 10 percentage kind of support for the product, end product. So it might be probably anything between 5 to 7% reasonable value if you consider as a booster for the buyer. I mean, this ultimately this subsidy is to be passed on to our buyers. So it will be only a 5 to 7% component contribution, and maybe in fact they will be doing a better support to the industry if they bring down the GST. That will be more visible and well understood number for everybody, rather than this kind of thing. In the sense, this can exist. We welcome even 1 rupee of subsidy. That is not the point. Point is, we have to also give some kind of that kind of a support which will motivate the industry to buy the product. So another thing is, they have to also give some kind of preference for those who commit to manufacture these electrolyzers under this scheme. Their electrolyzers should get some kind of ready acceptance as a vendor list of the government's projects or whatever buying policies, right? So that way, at least you are generating some kind of market opportunity and motivate the manufacturers to put their stake and get into the game.
Sure. If I just have to look into this number of 4450, which is around close to $55 per kilowatt of electrolyzer manufacturing, I'm seeing a lot of questions in our list coming from the audience. They are asking, like, what is the cost of electrolyzer, right? So assuming we are talking of a 5 megawatt unit or even bigger supplies, a 1 kilowatt electrolyzer cost, what is that number or range which is existing today across the different technologies? So Kiran, I'm not asking Plug's number or anything, but for PEM electrolyzer, the current economic, what's the current capex in terms of dollar per kilowatt? And I'm talking of big plants like 5 megawatt to 100 megawatt of installation. In that, like per kilowatt of PEM electrolyzer, and including balance of system, I'm saying, like not just the stack part. What numbers are we talking, Kiran?
See, there are broadly 3 levels of numbers that are floating around in the market. I'll start with the most exciting one, which is the Chinese electrolyzers. Someone was talking about $260 per kilowatt to $400 per kilowatt. So that numbers that number always is exciting and amusing at the same time. How they are able to do it, or is it what is actually leading to that? Because if you see from electrolyzer system perspective, stack of alkaline.
This is a system cost or this is a stack cost?
And this is the system cost is what the claim is, right? Okay. Let's ignore the 260. Let us take the 400, right? The difference between alkaline and PEM is only the stack, and the stack cost difference is not that high actually if you think about it, right? So how it is very low, we don't know. That is one. Second, the other cost I hear typically in the market about alkaline non-Chinese is in the range of anywhere between $500 to $800 per kilowatt, and PEM is anywhere between $800 to $1,200 per kilowatt. This is large systems at this given point. So depending on the application, depending on the engineering required, depending on the complexity, so you'll find this kind of variation.
Got it. And you have not told Plug's number.
Oh yeah, you
Chinese
can sign in
number,
India.
you have told non-Chinese number.
No, I'm saying if you can sign in India, I can give a proposal, not an issue. I mean, the reason is 1 megawatt, for example, in Europe is, I mean, I know that people have sold for $2 to $3 million, 1 megawatt. A 5 megawatt, people have sold anywhere between 6 million to 8 million, right? So it is not just about the stack cost. So a lot of other components and complexity comes into picture. So it's not very easy to put a dollar per kilowatt number, which is universally applicable. So that's the reason.
I just am hoping that in some time, with all the incentives picking up and entrepreneurs like Vishwanathan, supported by institutions like IITM, Kiran, yourself, we start having a third number, which is Indian electrolyzer manufacturers number, right? So that's a different version, Chinese, then Indian, and then we say non-Chinese, non-Indian. So what Murli, you would think like is that Indian electrolyzer, alkaline electrolyzer number, Arvind? What are you targeting? I know you asked me this question, but I want to ask you in front of the audience, Murli, like what is the number that you are targeting at a bigger megawatt level for per kilowatt alkaline electrolyzer for India?
Frankly, we would be more comfortable to answer this question after we put up a trial plan, because we would have arrived at some crystallization of the numbers. But for the sake of this, conversation, I would like to go with what Kiran has already told, because they are people who are professionally working in the field and they would know the numbers more confidently. But I would put this alkaline at $800 kind of number to be kind of considered for the sake of our conversation. Minimum of that,
Okay.
that should be the kind of thing. Yeah.
And you would agree to the benchmark or thumb rule that Arvind gave, that of this 45% is stack cost and 55% is systems cost, or you will say that stack cost will be higher?
No, the universally pie chart number is this, what Arvind ji has told, because that is what all the learned people have arrived at. But like I told you, we will have to again work on a project based approach, like what Kiran was telling. This is an engineering project and it all depends upon the various factors or parameters we take under a work order or a purchase order to bring out. So as of today, hydrogen manufacturing activity is not defined like a car on four wheels, which is a very clearly defined product. This has got so many factors and elements around it, which will change the price factor anyway. So we perhaps as a standalone product, electrolyzer can have a price tag, because it's a product which has got four corners and well defined. Other than that, balance of system is highly variable and that will be on a case-to-case basis. So it will have to evolve over time and depending on the end user's application. In certain applications, the user might already be using gray hydrogen and they just want to substitute the hydrogen generation part. Rest of the thing are there in their fold already. I mean, so many things are there here. So we'll have to kind of, I think not get deeper than this point, which we all are a little bit confident of answering you.
Sure, sure. No, I think this is good. We have gone a little over time, so I think time to kind of wrap it up. While I was asking questions, I kind of mixed a lot of audience questions that I was reading. So we have covered many of them. Still few remains unanswered. I think we will take it up them. Some of them not exactly fit relevance to this particular topic, so I'm skipping them in interest of time. Just for closing things, any last one thing that each of you would say would be the critical drivers for at multiple levels, like at the plant level, right, at the policy level, and at the demand level where actually the hydrogen needs to used. So are there any one very important thing you want to kind of add as a closure to this project, like at a plant level, policy level, and the end usage level for the audience? Anyone can take up a start.
Yeah, maybe I can finish it. Start with this one, Rahul. So the first thing that as a country we have to do is we have to have demonstrator pilots in order to arrive at techno-economic numbers, Rahul. That
Okay.
is the first and foremost thing that we will have to do. I think because companies are really like, we cannot just go by the economics just on the computer screen, right? We have to really put something into operation and get it. First thing is a successful demonstrator is what is going to attract investments, both in scale up for R&D and further push, right? That's a successful demonstrator is what, and I think Mr. Murali Vishwanathan also was pointing towards that. They couldn't come out with it because they don't have a full-fledged operating plan. Next thing is that we need to really have a proper validation testing labs across the country. You know, at the like kind of policy level. The last thing is, of course, when we consider the export market, what is that actual green? I think we discussed it multiple times. But anyway, what is that actual green in the green hydrogen? We need to really look at who is going to certify that. But the demonstrated unit should really take the first precedence, and it has to be either it's MNRE through this 19,744 crores. I think the first activity without any delay. I mean, that is what I find so disturbing. So much of delay. And that delay has to be somehow. There is a forum, Rahul, if you could help us talking there. I mean, I also talk, and also a lot of people talk. I think the delay is going to create a chaos. Without any delay, fund demonstrators, then country is going to be in track.
Thank you, Arvind. Pointed points. Kiran, you are more red on the points. The policy says start year 25-26 to 29-30. So which already is a 2 year from now, Kiran. So is that already a delay that you see, or how do you see that, Kiran?
And my only ask is the demand side of the story, because export is what renewable energy players are generally interested in, right? And we discussed about the banking thing. At least Europe says till 2029, same calendar month renewable energy production is adjustable for green hydrogen. So they are okay with it. The 1 month banking is okay for that. So that is what I think some players will be interested for building the domestic demand and also the potential. The R&D projects budget should be utilized on a fast track scale. So while we may not be able to go to 100 megawatts kind of thing, we should fast track them and keep it. I mean, see, we are in a learning phase, so we have to understand, we have to focus on learning things. Same problem happened with solar also. People say, oh, 17 rupees solar is impossible, but no one is talking about 2 rupees solar or 250 rupees or 250 solar. No one is talking about that, right? So that's a great achievement. We travel a long distance. So, but the initial foundation of solar is on that 17 rupees solar. So if we suddenly remove that 17 rupees solar, the whole solar industry does not exist. So we need to lay the foundation with right kind of projects, encourage institutions like PSUs, NTPC, IOCL, different sectors to do certain projects, do multiple technologies. So we get the experience, and therefore the merits of different technologies will come into picture, and therefore they will be deployed in the right places. It is not about competition between technologies. It is not competition between players right now, because the requirement is huge. As per one of the projections, as I said, 3,000 gigawatt is the world requirement. So, and India's energy consumption is going to grow, unlike other countries where it is going down possibly. So it's a huge number. So I feel instead of getting into the excessive analysis, we should go ahead and spend some money allocated for R&D projects and do multiple types of applications, multiple types of technologies, right? And then continue the push.
Like I told, for my
Sure,
point,
thank
as
you
a
very much,
last ask
Kiran.
is,
So that is the... Go ahead, Murli.
Now, maybe I don't know what happened with your audio.
Kiran used the word only ask, and Murli is
can I say one
concluding
last
with the
point?
word last. Okay. Yes, please, Murli, go ahead.
Yeah, the point
Murli,
is, like I told you, the tax concessions, that is very important from a push aspect for the marketing point of view. So just one incentive by the government by relaxing the tax for these projects will give some kind of indication that the government is, considering to nurture this baby in preference to other, commodities. Therefore, that kind of recognition is important. That is what I feel.
Sure. I think this is wonderful, guys. Between all three of you, we have a fairly good, strong set of recommendations. Just concluding, I think we should start with having more R&D pilots and not delaying it with whatever budgets in hand. And I think the mission has some R&D and pilots budget, so it should just be executed much faster. and of course driving more techno-economic feasibilities across applications, technologies is what we should look into. With more exports coming into the picture, what is green and those things, the labeling part, standards part, Arvind, P Manifold, ITM team, we are already part of working with MNRE on this particular part. So I know that it is taking up a good shape. So hoping to hear something more on that direction. And Murli's point in terms of the existing subsidy, though it's welcomed, but it is fairly minuscule. What will help the industry would be some kind of import duties relaxation, as well as the GST relaxation or exemptions, which has been done in past for other green technologies. So applying to that, I think will bring better viability and better demand generation, what Kiran, you were also stressing the need upon. So I think with this, I would really want to say thank you to our very esteemed panelists. Thank you to Saili for great share and working on the numbers. And definitely to all the audiences for being patient and bearing this time extension and asking good questions. If any of your questions remain still unanswered, we will try to answer them, but feel free to write to us and we will ensure that we try to give the best answers to them. So with that, I would like to close this webinar today and continue with P Manifold's Hydrogen Global Insights initiative and bringing more such experts and right discussions to take the momentum globally forward. Thank you, everyone. Thank you.
Yeah,
Thank you.
Nice meeting you, Mr. Murli and Arvind. Thanks, Rahul.
Thank you.
Yeah, nice meeting with you, Kiran and Vishwanathan. So we will discuss more over emails.
Yeah.
Yeah.
Thank you. Thanks, Rahul. It was a great webinar. Thank you so much for the opportunity.
Thank you. Thank you, Arvind. Take care, guys.
Thank you. Bye-bye.